Hello, welcome to a quick walkthrough of my AI workflows. My name is Addy. So first, we're going to start with the most simple Comfy UI workflow. Comfy UI is this UI that you see here. It's a node-based chain that you can connect and do things with AI models. Now, this is running locally on my computer. You can see up here, these are the system resources, but this could easily run on the cloud. This is node-based, meaning it's a visual programming language. So what is actually happening under the hood is this is creating a JSON file, a configuration file, which is going to run the code on CUDA on my NVIDIA GPU. So I have two models loaded here. The first one is the default text to image model that Comfy UI has. And the second model is something that I found online. It's an ArchViz model, so it'll give you more of a 3D game engine render look. So I just want to show you, just to give you a sense of what a model can actually do, influence over the final image. All right, so first I'm going to connect this checkpoint to the KSampler. So I'm going to just take this node here, connect it. The clip is basically the text. There is a positive text and a negative text, and these are clip encoders. So what they're going to do is turn ASCII text into a numerical representation in the latent space that the KSampler is then able to compute. I know that's a lot of technical terms. What is essentially happening is the input image is going into a mathematical higher dimensional space that is not representational of what RGB pixels are. It's going into what is known as latent space, and that's where all of the computation, the inference for the AI model happens, and it'll come out of the latent space, out of the KSampler, and go into what's called a variational autoencoder. It'll get decoded back into image space so we could see it as a RGB pixel or an image. The KSampler is the main engine of the inference here. So it is referencing that model that I showed you earlier. And then it's got the positive and negative clip encoded, meaning text encoded. So it has instruction on what you want it to do. And then finally, some of the other configurations here. This is the classifier-free guidance. So this weight will determine how much autonomy the KSampler has versus how much it wants to stick to the text. This is a random noise generator, as all diffusion models work on taking noise and then denoising it layer by layer, step by step into the image that we think we want it to make. And then finally, this is how many steps it'll take. It'll go through the denoiser 20 times, and then out it goes into this bucket. So right now I have my text set to city street with skyscraper, stores, cars, photoreal perspective from the middle. Great. This should give me like a New York-esque look. So you could see at the KSampler, there's a progress bar. So it's churning, it's doing a lot of neural network computation on the GPU. And it's done, and there is the image. So I'm just going to quickly show you here. This is the resulting image based on the prompt I gave it. Okay, great. So this is a very stylized look. I wanted more of a 3D game engine look. So what I'm going to do is just connect an entirely different model. And this model is based off of Flux, which is a very popular image diffusion model. So now I'm going to connect the model to the KSampler, a positive clip and a negative clip, and then finally the variational autoencoder into the decoder. So great, it's just connected like so. The old checkpoint is no longer being used, and now the new model is being used. I'm going to go through the same prompt and just run it all over again. And if we come to the KSampler, you could see on the progress bar that it's doing its thing. My GPU is at 100%. It's running, it's churning a lot of numbers, matrix multiplications and convolutions and so on. Awesome. So again, it gave me the perspective down the middle that I wanted, but you can see here the look is completely different. This very much feels like a video game, and that's exactly the model that I loaded. This is an overview of a very basic text to image generation using two different models, using a KSampler engine, variational autoencoders, and then clip encoders to get your text into the latent space. All right, so now let's go into more of a professional workflow. In order for me to really have control over the perspective of the city, I actually built a quick scene here in Unreal. As you can see, this took me like 5 minutes to do. It's just basic cubes, and you could real quickly, start to make it more complex. I'll show you here. One of the views that I want is just from the middle of the street, looking down like this, looking down into the avenue. Maybe back up a little bit, something like that. So I'm going to grab this image, and then I want maybe another view that is just from the side like this. Just maybe looking around this corner, something like that. So now that we have all of our shots from this quick 3D city that I built, I'm going to get out of Unreal, get back into Comfy UI. Okay, so this is my, what I would call a professional text-to-image generation workflow. There's a lot going on here, so I'm going to walk you through it all. I am going to hide all of these wires. So now the wires are hidden. So remember the Unreal scene that I opened up and I dialed in a couple of the looks that I wanted. So I'm going to load a file here from there. So I really like this overhead drone shot looking down into the middle boulevard. And I want the AI model to basically texture this and render this. And I'm giving it basic structure. So this is one way to what I would call fine tune a model. So take a little bit of control over the model output. The way we're doing it here is through something called ControlNET Union. So in very basic terms, it's taking a bunch of different ControlNET inputs. ControlNET is a way to have significant influence over the final result, fine tune, if you will, using different methods. So you have a line art, so turning things into fine pencil sketches, soft edge. So this is edge detection. Canny, this is more of a harder edge detection. And then depth map. Depth map is just taking a 2D image and figuring out in the Z direction what depth it is. Open pose, this is more for humans. We're not going to be using open pose today because we're just doing cityscapes. And then a scribble and sketch. So if you actually use a pen and paper, you can upload that as a way to influence your model. Excellent. And up here, I have the controls to turn things on and off. So I'm going to turn off depth and scribble and sketch. Yes, I want the output. Yes, I want the prompt and the input. I'm going to turn on line art, and you could see that these nodes all of a sudden are now active. They're in play. So this model is just going to generate the line art and nothing else. And then we're going to take that line art into an input into the main KSampler, which you see here. Excellent. So on my prompt, I have New York City, busy streets, photoreal, and cinematic. Okay, great. And I'm going to hit play here. So now you could see that it is going into the clip. So this is deciphering the text prompt and then turning it into a representation that the latent space can then take. And then here it is. We see a line drawing done from, yep, this is very consistent. You can see the basic structure of that perspective. I'm pretty much high as a drone looking down into the city. And now you can see the KSampler doing its thing. Okay, so it's done. And you can see here that definitely kept the perspective of that boulevard down the middle. I'm not a big fan of all the billboards, but it did give me the sort of the result that I wanted. Excellent. So now I'm going to use a different fine-tuning method. So I'm going to turn line art off, and now I'm going to turn on depth. And let's try a different input image. So I really like this perspective here. You can see the little sliver of background sky in between the tall skyscrapers. So, and instead of line art, we're going to use a depth map. So right now it's going to go from the clip into this control node. Oh, there you have it. You can see the depth map was produced by the ControlNet here. And the black means it's just further away from where you're standing. white is closer to where you're standing. And it's just a 2D image. Okay, now the KSampler is doing its thing once again. You can see the progress bar here. Oh, wow, look at that. That kept the perspective exactly how I wanted. So yes, from the depth map, this stuff is supposed to be really close to you, and then stuff that's really far away from you was in black. So yeah, the sky is back there. So it kept some of the structures of the building. I'm really happy with the result, and you could see clearly here that this is not random. I had significant influence over the structure of this generation here, and this is how in a professional setting you would start to control things. And images are the foundation of videos. So if you're going to generate videos, you would use a lot of frames of images and then influence the video generation based from those images. Thank you for your time, and I'll see you soon.